So, Assalamualaikum Jamila dan Jamil, Jamils lah. Okay, so basically I just want to take this few moments to explain a bit again about retention time and also resolution in liquid chromatography. Liquid bukan gas. Okay, so in liquid chromatography, we have partition chromatography, and then can be divided into normal phase and reverse phase. So yang ni semua you dah hafal. Stationary phase is polar, mobile phase is less polar, and the one that will be eluted first is the least polar. And then but in my previous video, I forgot to consider the retain component. Okay, so retain component is the one that will follow the stationary phase. So for example, you have three types of analyte: analyte A, analyte B, and analyte C. So analyte A is apa? Analyte A, for example, is polar. Analyte C is non-polar, and then analyte B, for example, intermediate lah, contoh. Okay, so the polar analyte in normal phase, the polar analyte will retain. So this will retain, and then you punya the non-polar analyte will be eluted first. So what happen if you increase the polarity of the mobile phase? So if you increase the polarity of the mobile phase, means that your mobile phase will be polar. So what happen is that this polar analyte will be eluted together with the mobile phase. So this polar analyte will consider to leave the stationary phase and then follow the mobile phase and then being eluted. So bila dia tinggalkan stationary phase, dia follow the mobile phase. Mobile phase you jadi polar tadi sebab you increase. So when you follow the mobile phase, it will decrease the elution time. So this will reduce the elution time. So when it comes to elution time, the lecture note or the question tomorrow, they are talking about the whole analysis time. Whole analysis time. So the one that will determine this whole analysis time is the retain component. This is what I forgot to mention yesterday in my previous video. So let's move on to the reverse phase. Reverse phase, you dah tahu stationary phase is non-polar, mobile phase is polar, and then the polar will be eluted first, but the non-polar will retain. This is the one that will determine your elution time. So what happen is that in the reverse phase chromatography, let's say if you have an analyte A, analyte B, and analyte C, sama juga. So analyte A being the most polar, analyte C is the non-polar, analyte B is the intermediate. So if you are using reverse phase analysis, the non-polar analyte will retain together with the stationary phase. So what happened when you increase the mobile phase polarity? Increase mobile phase polarity means that your mobile phase will be polar. So what happened is that the non-polar analyte ni that will determine the elution time, what happened to it? Will it continue to stick with the stationary phase, or will it follow the mobile phase? Yes, of course. If you increase the mobile phase polarity, the retained analyte will continue to follow the stationary phase. It will remain retained. So this will increase the elution time because the retained component will remain retained. Okay? So how do you want to decrease the elution time in reverse phase? You can decrease the polarity of the mobile phase. That is, the mobile phase should be less polar or non-polar. So when the mobile phase is non-polar, your retained component will consider to leave your stationary phase and follow your mobile phase. So this is how you can decrease the elution time in reverse phase. So let's take a look at this example. I think this is question 2019 if I'm not mistaken. I spent the whole night cari balik you punya past year's question. So what happened is that you have two chromatograms here, chromatogram 1 and chromatogram 2. So you can see here this chromatogram is overlapping when they are using 50% methanol and 50% water. So what happen is that you know that this is polar sebab dia reverse phase. So the analyte will be eluted first is the polar. So the analyte will be eluted last is the non-polar. So as you can see here, the non-polar analyte is elute faster than you want it to be sebab tu dia overlapping dengan the polar analyte. This means that this mobile phase is non-polar. Okay, sebab tu dia follow the mobile phase and then dia jadi overlapping. So how do you want to reduce the retain component or the non-polar analyte to retain in the stationary phase and taking their sweet time to be separated? So you can do by increasing betul lah. So you can do by increasing the mobile phase polarity. So when you increase the mobile phase polarity, the non-polar analyte dia tak nak follow. They will not follow the mobile phase and then they akan retain in the stationary phase. Betul? Okay, so when they retain in the stationary phase, it will allow the polar component to jalan dulu. So polar component boleh jalan dulu. Okay, dia akan keluar dulu, followed by intermediate, and then barulah dia keluar. And then you can see and then you can get a good resolution. Boleh follow tak? Boleh faham ke? Same goes to question. Kalau question tanya retention time lah. Macam I explain tadi previously. Okay, boleh follow ke? Good luck.